recorded. Okay, now so in between while I'm taking class, please don't make noise. Understand or no? And please don't try to disturb the class. If you want to disturb the class, please leave itself, please now itself, or otherwise I will, it means that I will turn off all your mics and cameras. Already I have been turned off all your cameras. Okay na? So if you, for today I'm giving permission that I am allowing you to speak during the class. Okay na? So if you have any doubts or if you want to speak anything to me, you can speak. Okay na? Unnecessarily don't speak anything and don't turn on your mic. Understand or no? Okay.
Yes, sir.
Okay, in previous class we were discussing about the curves. Okay, now so what is the necessity of curves, and in civil engineering class practices where we use curve setting. Okay, and what are the different types of curves we have seen. Understand? So basically depending upon their shape. Okay, so there are two types of curves are there. Okay, so one is the circular curves and another one is the transition curve. Okay, now it means that wherever we want to connect the two lines or two roads. Okay, it means that basically in civil engineering practices the curves will be used whenever we want to change the direction of the vehicle, or we want to change the motion of the vehicle in from one direction to another direction. In that case we can provide the curves. Okay, now so whenever we want to change the direction, in that case we can use the horizontal curve, and whenever we want to change the gradient or height or level of the vehicle upon the road itself, in that case we can provide a curve. That curve will be called as the vertical curve. Okay now, so basically there are two types of curves are there. One is the horizontal curve and another one is the vertical curve. Okay now, so whatever may be, either it is curve, it means that either it is horizontal curve or vertical curve. Okay now, so the setting of process is same. Okay now, so what are the different components of curve also we have seen. Okay now, so what are the different components of curve we have been discussed in previous class? Can anybody tell me? First of all, what is curve? Anybody can answer? I'm asking what is curve? CURVE, curve. No one? Twenty-one BK 580 140 140. Are you there? 131. Okay, I will tell you. The curve is nothing but a part of a circle, or simply you can call as an arc of a circle, can be called as the curve. Okay, now so or one more another, in another way also you can define a curve like whenever you take a straight line. Okay, so if you bend the straight line like this, okay, so then it can also be appear like a curve. Okay, so the bend of any straight line or an arc of any circle can be called as the curve here. Understand now? So that's what we have been discussed in previous class. Okay, now in today's class we are going to discuss about two concepts basically. One is the setting out of curve in earth surface, that is the one concept, and another concept we are going to discuss is that EDM, electronic distance measurement. Okay, now so these are the two concepts we are going to see in today's class. If you want, you can make a note. Okay, now yeah, just I will explain you all the components of the curve. Understand now? You can see here, this is the curve. Okay, now so T1 and T2 are the, they will be called as the tangent points. T1 is the first tangent point and T2 is the last tangent point. And the curve, and one more thing, two lines are there. One is AB and another one is the BC. Okay, now so AB is a line and BC is a line, and both the lines are in different directions. Okay, now so whenever the vehicle one, it means that AB here what you understand that AB is a road and BC is a road. Okay, now so whenever the vehicle wants to what you call travel from AB road to BC road. Okay, so in that case we have to provide a curve to the vehicle to convert or to change its way. Understand? So from T1 is the point on the AB line where it means that the curve have been started. It means that where the vehicle wants to change its direction. Okay, and T2 is the point on the line BC or road BC upon which where the vehicle can join the another road. It means that can join the road BC. Okay, now so T1 and T2 are they can be called as the tangent points, and T1 is the starting point of the curve, and T2 is the ending point of the curve, and AB is the tangent line, and BC also a tangent line for the curve. Okay, and the F is the center line of the arc, sorry, center point of the arc, and T1 F T2. Okay, it means that the distance or the length of the curve or the distance between the T1 and T2 points over the curve. Okay, it means that T1 F T2. The distance can be called as the length of curve here. Okay, and T1 to T2 directly, if you draw a straight line from T1 to T2, okay, so that straight line can be called as the chord, CHORD, chord of the curve. Okay, now so here T1 F T2 can be considered as the length of curve, and T1 E T2 can be considered as the length of chord. Okay, now so and one more thing I told you that if you take a circle, definitely every circle can have a center. Okay, now so here O is the point. It can be considered as the center of circle. Okay, now, but here we don't have the complete circle, we have only an arc of circle, that is curve here. Okay, now so that's why the O can be considered as the circle for the curve. Okay, now so O is the circle of the curve, and O to T1, if you draw a line, it can be the R radius. Okay, now so that radius can be designated as R. Okay, now so if you draw any straight line from O to any point on the curve, okay, now so then definitely it will be the radius. Okay, now so R have been written, and one more thing here you can see the line AB is there and the line BC is there. Okay, now so if you extend the line AB, then it will be A to B to B dash. Okay, it means that the AB line have been extended till B dash. Okay, and the line BC is there as it is. Okay, so the angle between the AB dash line and BC line can be, it means that it is here designated as pi. Okay, so what is pi here? Can anybody tell me what is pi here?
Deflection angle.
Yeah, pi is the deflection angle here. Okay, now so and one more thing I told you that from this circle, okay, now so sorry, from the center of the arc, from the center of the curve to the curve, if you draw any line, it will be the radius. Okay, now so T1 is the starting point of the curve and T2 is the ending point of the curve. Okay, now so from O to T1 and from O to T2, if you draw two lines, they will be the both will be the radius of the curve. Okay, now, and the angle between the two lines at center O will be equal to the deflection angle what it is making as pi at B. Okay, now so angle B dash BC is equal to pi in the same way. At circle O, it means that at center O, the in center angle also will be equal to pi. It will be the deflection angle. Okay, now and we know whenever we take a straight line, the angle on the straight line will be equal to 180 degrees. Understand? Now? So the angle on the straight line always be equal to 180 degrees. That is another thing we will see there. Okay, now so these are all the different components of this what you call curve here. Okay, and also we have seen different it means that different terminology and different components how to determine them. We have different formula. Okay, now so angle of intersection I plus angle of deflection or deflection angle will be equal to 180 degrees here. Okay, now you can see here I is the angle of intersection and pi is the deflection angle here. Okay, now and the point B can be considered as the what you call the point B can be considered as the point of intersection. Okay, now so the angle between two tangents at B can will be I, angle of intersection. Okay, now and the deflection angle means whenever the it means that the what the projection of forward line and the what the projection of the previous line and the forward line. Here AB is the previous line and BC is the forward line. Okay, now so AB line have been extended. Okay, now so that's why the extension of AB line will make an angle with BC line. It will be the deflection angle pi. Okay, and the angle between AB line and BC line will be called as the angle of intersection, and that is equal to pi. Sorry, I. Okay, so therefore AB B dash is a straight line. Okay, so that's why pi plus I is equal to 180 degrees. Understand or no? That's what is seen here. Okay, now angle of intersection plus deflection angle will be equal to 180 degrees I plus pi is equal to 180 degrees. Okay, and then the angle between the two tangents can be calculated as the 180 degrees minus I. It means that pi we have seen in the figure. Okay, now and next tangent length can be calculated bt1 or bt2. Both the tangent lengths can be calculated by using the formula r tan pi by 2. This is the formula what we can use to determine the tangent length. Okay, now it means that first we have to by using the r tan pi by 2 formula. Okay, now by using this only we can set up the tangent length. Okay, now so then only mean that when we go for in realistic case. Okay, now so r tan pi 2 formula use చేసి మనం ఏం చేస్తాం చెప్పండి, what you call the tangent length. It means that b to t1 and b to t2 distance we can get. Okay, now so by using the tangent length only we are going to set up the t1 point and t2 point. Okay, now it means that r tan pi by 2 formula, it is the formula used to determine the tangent length. It means that the b t1 distance and b t2 distance we have to know. Okay, and then based on that distance only we are going to set up the point t1 and we are going to set up the point t2 on the two lines, and then we can set up the curve between t1 and t2. Understand now? So that is the important thing. First of all we have to calculate the deflection angle there, and after that immediately we have to calculate the tangent length r tan pi by 2, and yeah, that thing whenever you determine that r tan pi by 2, so then we can able to know that where we have to start the curve at first line and where we have to end the curve on second line. Okay, now so this is the what you call important thing we have to determine. And after that length of long chord, yes, yeah, we have been seen now t1 is the starting point of the curve and t2 is the ending point of the curve, and if we draw a straight line from t1 to t2 it will be called as the chord, long chord. Okay, now so the length of long chord can be calculated by using the formula 2r sin pi by 2. Understand now? So 2r sin pi by 2, by using this formula we can calculate the length of long chord, and then length of curve we can calculate. It is easily we can calculate. Okay, so pi r into pi, radius into pi, radius into deflection angle. If you multiply the deflection angle with radius you can get the length of curve. Okay, now it will give in terms of radians. Okay, now so we have to convert that radians into degrees. That's why we have to divide that into pi by 180. Understand? So pi is the 22 by 7 and 180 is the, it means that what you call 1 degree is equal to 180 radians. Okay, so that's why we have to convert, we have to multiply it into pi by 180. Sorry, r pi into pi by 180. It means that if you multiply that, if you multiply it by using pi by 180, then only we can convert it into radians into degrees. Okay, now so length of curve can be calculated by r pi into pi by 180. That is the formula. And apex distance we can calculate by using the formula r secant pi by 2 minus r of 1 minus cos pi by 2. By using that also we can determine the apex distance. Okay, now so here bf is the apex distance. You can see here in this figure d is the point of intersection of two tangents and f is the center point of the curve. Okay, so the distance between the b and f will be called as the apex distance. Okay, now so that apex distance is also most important parameter. Okay, now it means that whenever we go for the setup of curve, okay, now so the apex distance also can play an important role. Okay, now so the apex distance can be calculated by using the formula r. You can see here r secant pi by 2 minus r, or r of 1 minus cos pi by 2. Okay, now so these are all the things first of all we have to determine. It means that in field whenever we go for a setup a curve, okay, now so first of all the things we have to calculate. Okay, now after having all these calculations only we have to go the field for setting out a curve. Okay, now and in our laboratory our next experiment is setting out a curve. Okay, now next we are going to set up a curve on the earth. It means that in the field, then you will understand. Okay, now nothing we have to do. First we have to calculate the deflection angle. After that we have to calculate the tangent length. Then we will calculate the length of long chord. Then we will calculate the length of curve, and after that we will calculate the apex distance. Okay, now we have everything. We have every data. Okay, so then automatically we can set up the curve on the field. That's it. It is too much easy. Okay, now so that's all. And one more thing, the designation of curve. It means that whenever we have to mention the curve or whenever we have to discuss about the curve, okay, how can you discuss about the curve or how can you define a curve? Okay, now so it can be that, it means that the curve can be defined or the curve can be explained in terms of its degree or explained in terms of its radius. Okay, now so the quantity of curve or the magnitude of curve can be expressed in terms of its degree or can be expressed in terms of its radius. Okay now. So in some countries the curve can be expressed in terms of its radius, and in some countries the curve can be expressed in terms of its degree. Okay now. So there is a degree is nothing but the center angle. Okay now. So radius is nothing but the radius of the curve. Okay now. So degree is nothing but the center angle at the center of the curve between the first radius and the last radius of the curve. Understand or not? So that angle between the first radius and last radius will be called as the degree phi. It is equal to deflection angle or it is the center angle. Okay now. So there is also a relation between the radius of curve and degree of curve. Okay now. So that is the this is the relation r is equal to 15 into 360 divided by pi d, or it can also written as r is equal to 1719 divided by d. Okay now, where r is the radius and d is the center angle. You can see in this figure. Okay now. So O is the center of the curve and R is the radius, and again R is the radius. Okay now. So first radius will be there, last radius will be there, and in between the first radius and last radius some angle will be there. That angle can be taken as the degree of curve here. Okay now. So this is the relation between radius of the curve and the degree of the curve or center angle of the curve. That's all. Okay now. So till now we have been discussed in previous class. Okay now, and in this class I am going to discuss about you methods of curve ranging or methods of setting out a curve. Okay now, so the setting out, we can set up a curve by using two types of instruments. Okay now, so one is the instruments will be used for linear measurements, and another one is the instruments will be used for angular measurements. Okay now, yeah, the first method will be called as the linear method and the second method will be called as the angular method. Okay, so for the PPT is not visible. Really tell me, PPT is visible or not visible? To all of you, PPT is visible or not visible? It is visible or no?
Yes, sir, it's visible.
Now it is visible or since
At-
initial it is visible?
since starting of the class is what visible, sir. Even the diagram also I have drawn it.
Okay, I think now it is visible to all. Okay,
Yeah.
na? Hmm. Okay, by using a curve may be set out by linear methods where chain and tape will be used, and one more method is that by using angular method or instrumental method where we can use the angle measuring instruments like theodolite, compass, etc. or EDM, total sectional, etc. Okay, now, so by using this method, these kind of instruments we can set up the curve. Okay, now, alone by using linear instruments we can't set up the curve, and alone by using angular instruments we can't set up the curve. Okay, now we have to use both the things. Angle measuring instrument should be there and linear measuring instrument should be there. Okay now, so both should be there, and sometimes we can omit angular measuring instruments like when we go for the set out a curve by using offset method. Okay, in that case we can omit the angular measuring instruments, but only by using the offsets, by drawing the offsets to the long curve. Okay now, so we can set up the curve. In that case also for measuring the deflection angle as well as for measuring the what you call center angle, we can calculate them. Okay now, even for accuracy or for checking them we can use the angle measuring instruments, and then we can confirm that our the curve whatever we have been set it is safe. Okay now, so these are the two kinds of instruments we can use for setting out a curve. Okay now, so these are all the different methods what we can use for setting out a curve. Okay now, so one is the Rankins method, and another one is the offset method, and another one is the two theodolite method or three theodolite method. Okay now, three methods are there, and in most of the cases two methods will be used, Rankins method and another one is the offset method. Okay now, so whatever we have been discussed initially, it means that all the formula we have been used now. Okay now, so the formula used for determining the deflection angle, formula used for measuring the tangent length of long curve, length of curve, apex distance. Okay now, so all the what you call all the components of the curve we will determine, and then we go to the field for setting out a curve. Okay, so that method will be called as the Rankins method. Okay, and another one more method is there, that is the offset method. Okay, so here that is the Rankins method. In Rankins method first we will determine all the components of the curve by using the formula, and then we go to the field by taking theodolite, we take the theodolite there. It means that we are determining deflection angle and center angle now. Okay, so to setting out that angles, okay, now we can take the theodolite to the field, and then we can set up the curve. Okay, now but here this is the method of what you call offset method. Okay, now so in this offset method, you can see we can set, it means that we will set up the card, the length of long card we will set up, and from the length of long card at one side we will set up different offsets with the different distances or with the different lengths. Okay, and then we will connect all the offsets at their ends. Okay, so then it will form a curve. That's all, it will form a curve. Okay, so two methods are there. Okay, so offset method, Rankins method, and two theodolite method and three theodolite method. Okay, you can see here. First, we will see both procedure for both the methods. Okay, you can see here procedure methods of setting out a curve. Okay, now first we have to see. You can know first after fixing the directions of the straight lines. Straights means tangent lines here. Okay, now so AB line and BC line. Straight here, the straight is nothing but tangent lines are roads. Okay, now so first of all we have to fix the straights to produce the meeting pointer, to produce the point of intersection B. Okay, now so after that we have to set up the point of intersection B first of all, and after that at the point of intersection B we can measure the intersection angle I. Intersection angle we can measure them. Okay, now so then deflection angle can be calculated by pi is equal to 180 minus I. Okay, now so understand now. So first of all we have to set up two straight lines. After that the what you call the intersection angle we can determine. Okay, and then the intersection angle can be determined, and 180 minus intersection angle will give you the deflection angle. By using the deflection angle we can project the previous line or first line. Okay, now so then up to this we have been calculated the deflection angle. Okay, and after that by using the deflection angle we can determine the tangent length r tan pi by 2. Okay, now so by using this formula we can determine the tangent length. Okay, now so then uh, after determining the tangent length we can get the bt1 distance and bt2 distance. Okay, now so by using this distance from the point b, t1 on the ab line and t2 on the bc line, we can fix 2 points, and then t1 is the starting point of the curve on ab line and t2 is the ending point of the curve on bc line. Okay, now like that we can set up t1 point and t2 point on both the lines. Okay, and after that we have to go for the chainage. Okay, after locating the positions of the tangent points t1 and t2. Okay, so their chainages may be determined. Yeah, their lengths also will be determined from which point we are going to find out the t1 and t2. Okay, so their chainages will be determined, and after that, after knowing the chainage, we can set up the pegs at equal intervals on the curve. Understand, Anna? That equal intervals can be calculated by using the Rankins method. Okay, now some formula will be there. By it means that deflection angle will be there at the point of B. Okay, now and again some more angles we can those angles. Understand, Anna? So that angles can be calculated from station A, or as well it means that 2 points will be there. Now T1 and T2 you can see here. This is the curve. Wait, I will show you there. This is the curve. Okay, now so T1 is the starting point of the curve and T2 is the ending point of the curve. Wait a minute. Yeah, this is the curve, simple circular curve. Okay, now. Yeah, T1, first of all we have to fix the point B. AB is a line, BC is a line. The two lines are, the two directions will be there on the ground itself. Okay, now so first of all we have to set up the point at B. It means that we have to fix the point B. Okay, and then the angle between AB line and BC line will be the angle of intersection. Okay, so by using that angle of intersection we can project the AB line. It means that by fixing the deflection angle, that pi deflection angle can be calculated by using the 180 minus I. Okay, so then we will get the deflection angle, and after that the the what you call the tangent length b to t1 and b to t2, the lengths bt1 and bt2 will be called as the tangent lengths here. Okay, so by using the respective formula, understand? So tangent length can be calculated. See here, this is the formula here, r tan pi by 2. Okay, so by using this r tan pi by 2 formula, we can calculate the bt1 length and bt2 length. Okay, now by using that length, after calculating it, we have to set up a peg at t1 and a peg at t2. Okay, so then t1 is the starting point of the curve on ab line, and t2 is the ending point of the curve on bc line. Okay, now so then after that, from t1 at regular intervals we have to set up pegs, and from t2 at regular intervals we have to set up pegs. Okay, now and the regular intervals can be calculated by using the Rankins method. The Rankins method is, it is a separated derivation. Okay, now so about the Rankins method or about the derivation we will discuss hereafter. We will discuss. Okay, now so at regular intervals we will set up pegs. Okay, and then we will draw a line through the pegs. Okay, so then it will form a curve. That's all. Understand? Now you can see here, measure the t1 t2, and okay, now you can see here, after locating the positions of the tangent points t1 and t2, their changes will be determined. Okay, now and t1 change and t2 change will be determined. Okay, now and after that some what you call angles can be determined, and then by using that angles at regular intervals we can set up the pegs on the ground. Okay, now so then you can see here, and the next one more thing you can see here, then pegs are fixed at equal intervals on the curve. Okay, and then the interval between pegs is equally 30 meter or one chain length. Okay, now it means that that 30 meter or one chain length can be taken. Okay, now it is the approximate method we have to take. Okay, now but actually this method cannot be taken. It means that a 30 meter one chain length cannot be kept as one regular interval. Okay, so that regular interval can be kept by some angles. Okay, now from t1 and t2 different angles can be taken. Okay, now with that angles in the direction we have to set up the pegs. Okay, now so how to calculate that interval angles we will discuss later. Okay, now so that is a separate task there again. Okay, now okay, now so the distance could the interval distance. Okay, now so this distance should actually be measured along the arc, or even if you measure along the arc it can give, or even or the intervals at the end of the lines, if you connect them also it can form a arc. Okay, now then it will be the curve. Okay, now and you can see, but in practice it is measured along the chord, as the difference between the chord and the corresponding arc is small and hence it is negligible. Okay, now it means that the difference between the chord and the arc it is small. Okay, now so then it will be negligible. Okay, now so that's why if you determine the angle, interval angle, and then if you set up the pegs and then if you connect them, okay, now so then accurately it will form the curve. Okay, now that's what they are coming to say. Okay, and one more thing, the length of chord should not be more than 1 by 20th of the radius of the curve. Understand? Anna? So always the length of chord should be less than 1 by 20 what you call quantity of the radius of the curve. Okay, now so this is the one of the important thing we can remember, and no need to remember because always it will be like that only in the field. Okay, now so the curve is then obtained by joining all these pegs. That's all. Okay, now so first of all we will determine all the things by using the formula. After that t1 t2 points we have to fix in the field. Okay, and then from t1 t2 regular what you call interval angles can be calculated. By using that interval angles in the direction we can set up pegs. Okay, and then if you connect all the pegs it will form a curve in between t1 and t2. Okay, so then the distance, if you draw a straight line from t1 to t2, then it will be the long chord, and the length of long chord can be determined by using the chain or tape. Okay, so that's all. Okay, so this is the setting out of a curve by using the Rankins method. Understand now? And one more method is there, it is the linear method. Okay, now so in this method will be called as the setting out of curve by using offset. Okay, now so this is the offset method of setting out curve. Okay, now so the following are the methods of setting out of simple circular curves by use of chain or tape. Okay, now so offsets from tangents we can draw and then we can set out a curve, or successive bisection of arcs Okay, we can do, and also offsets from cards produced. Yeah, from the card you can set produce different offsets at one side, and then also we can draw a curve. Okay, so three methods were there. Before we do discuss about this, okay, now you can watch a small video. Okay, I would like to play a small video. You can watch it. You can watch it on about curves. Okay, now. Guys, video is visible to you.
Curves are provided whenever a road changes its direction from one to another, like from right to left or left to right, up to down or down to up, etc. Sometimes road does not change its direction, but still, however, road curves are recommended to be designed. Such situations may come when road alignment passes in historical places or graveyards which cannot be destroyed for the purpose of road construction. Road or highway curves are serious in both pavement and geometric designs. Road curves are provided with a maximum speed limit that should be followed very strictly. It is very necessary that appropriate safety measures be adopted at all horizontal and vertical curves to make the infrastructure road user friendly and decrease the risks of hazardous circumstances. Two types of road curves are normally provided for the age of the driver in road as follows. The number first can be the horizontal curves and the second can be the vertical curves. Let's talk about the horizontal curves. Road curves which are provided in the horizontal plane are known as horizontal curves. Horizontal curves can be an arc of a circle, spiral, an ellipse, or a parabola and a hyperbola. So we can have some classes of a horizontal curve. For example, a simple arc provided in the road to impose a curve between the two straight lines or tangent lines is known by a simple curve. The combination of two simple curves combined together to curve in the same direction is known by the compound curve. Now the combination of two simple curves combined together to curve in the opposite direction is known by the reverse curve. And a curve that has a varying radius is called with a transition curve. Remember, a transition curve is not a circular curve. It can be the part or the portion of an ellipse, spiral, or a parabola. This type of curve can be provided with a simple curve and between the simple curves in a compound and reverse curve. The length of a simple, compound, and reverse types curves can be found with the help of the given formula. L equals pi r pi divided by 180 or L equals pi divided by 360 times 2 pi r or L equals pi divided by 360 times pi d, where L equals the length of a circular curve, r is the radius of the curve, d is the diameter of the curve, and pi is the central or deflection angle of the curve. And furthermore, the length of a transition curve can be calculated with the help of the following three methods. These include by definite rate of superelevation, by arbitrary gradient, and by the rate of change of radial acceleration. I have already uploaded a separate video on these three methods. You can watch that video in the land survey playlist on this channel. And now let's talk about the vertical curves. Vertical curves are provided to change the slope in the road which can and cannot be symmetrical. Vertical curves are parabolic, not circular like horizontal curves. Vertical curves can be in the sag as well as in the crest form, which depends upon the position and direction of the road alignment. For example, The sag type vertical curve are provided when the alignment of the road changes from uphill to downhill. Similarly, crest curves are those which change the alignment of the road from downhill to uphill. The vertical curve can be provided in the following four conditions. Number first is when the alignment is from the positive to negative gradient. In such a case, the curve is known by the crested curve. In the second condition, when the alignment is from the positive to positive gradient, in this case the curve can be formed as a sag type curve. Sometimes the alignment leads from negative to negative gradient, which also brings us of course a crested type curve. And finally, the alignment can also lead from the negative to positive gradient, which of course brings us a sag type curve. The length of a vertical curve can be determined with the help of the given formula, which can also be of course revised. The length L equals G1 minus G2 divided by delta G, where of course G1 minus G2 is the total change in gradient and delta G equals the rate of change in gradient. And that's it. So this was a short presentation about the road curves. Hey, if you like the video, please hit that subscribe.
Yeah, guys, see, I think from this video you can understand. Okay, so how to set up it means that what are horizontal curves and vertical curves and transition curves, and where to set up all these things. Okay, I think you might have learned. Okay, and still, if you have any doubts in curve setting or different types of curves, okay, you can ask me. Yeah, one more method of setting out of horizontal curve or circular curve is the offset method. Okay, now so first of all, the offset method, it means that offset is nothing but we know what do you mean by offset. Okay, now so offset, what do you mean by offset? Offset is nothing but any line which is drawn perpendicularly to a survey line to any object. Okay, now so that line can be called as the offset line here. Okay, now so by drawing offsets to the chord or by drawing offsets to the what you call tangent. Okay, now so we can draw the, it means that we can set out a curve on the ground or field itself. Okay, now so that's why offsets are set out either radially or perpendicular to the tangents. Understand? So if you set up radially, it means that in that case the offsets are perpendicular to the chord. If you set up perpendicularly to the tangent, okay, so that's the second method. Okay, so in both the methods we can set up the what you call offsets here. Okay, now in this method you can see here this is the tangent AB and tangent BC. Two tangents are there. Okay, now so perpendicular to the tangents here they are setting out a curve. Okay, now sorry, first they are setting out the offset here. Okay, now so you can see here O2 T1 a line is there and a line AB is there. Okay, now so in that case they have been assumed that the angle, it means that OT1 line, it is the radius of the curve anyhow. Okay, now so it is accurately 90 degrees with the line AB. It means that it is perpendicular to the tangent line. Okay, now so then with regular intervals to be calculated now for drawing or for setting out the offsets here. Okay, now so that interval of offset can be calculated here. Ox is equal to square root of r square plus x square minus r. Okay, now so therefore it can be also written as Ox is equal to x square divided by 2r. Okay, now so by using this distance we can get up the interval between the offset as well as the length of the offset we can get here. Okay, now so Ox is equal to x square by 2r is the formula to know the offset, how much offset to be kept. Okay, now you can see and x is the spacing of the offset here. Okay, now x is the spacing of the offset, you can see from the figure, and Ox is the offset, how much offset to be kept there. Okay, now so from there. Okay, now so that's why understanding. So from this You can see from the figure, you can understand. Oh, first, second offset, third offset, like that. X is the spacing between the two successive offsets. Okay, now. So by using the formula, we can set up the x distance as well as ox distance. Okay, and this is the one more method. Okay, now, this is the one more formula we are having. Ox is equal to x square by 2r. Okay, now, so by using, it means that this is that when we have to set up the offset which is perpendicular to the, sorry, offset which is radial to the, what you call, tangent or perpendicular to the chord. Okay, and in both the cases we can set up the offsets here. Okay, so whatever the method, this is the procedure to set up the curve in the field by using the offset. Okay, now you can see here, locate the tangent points t1 and t2 on both the tangents first of all. Yeah, in case of ready Rankine method or in case of offset method, the first thing we have to set up is the t1 on the line AB and T2 on the line BC. Okay, so the T1 to B and T to B, that length will be called as the tangent length here. Okay, so the tangent length can be calculated by using the formula. How can you calculate the formula? Tangent length is equal to r tan pi by 2. R tan pi by 2. R is the radius. Okay, and pi is the deflection angle. R tan pi by 2. By using that formula, we can calculate the BT1 and BT2 distance, and then we can set up the T1 and T2 there. T2 there. Okay, and then measure equal distances 50 meter or 30 meters along tangent from T1. Okay, now it means that equal distances we have to set up. Okay, and then set out the offsets calculated by any of the above methods. Okay, now by using any of these two methods, we can set up the offsets for one method and second method. Okay, now so we have been discussed about any of the method, we can set up the offsets at required points. Okay, now, and then continue the process until the apex of the curve is reached. Okay, it means that till that we have to keep on setting out the offsets. Understand? So first offset, second offset, third offset, like that. We have to keep on setting out the offsets on the offsets from the tangent until we reach the apex of the curve. Apex means, what is apex here? B point will be called as the apex here. B is called as the point of intersection. B is also will be called as the apex here. Okay, until we reach the B, we keep on setting out the offsets there. Okay, now until apex of the curve is reached, then set out the other half of the curve from the second tangent. Yeah, first we have to set up the offset from T1 to the apex, and then again from another side. It means that from T2 to the apex, we keep on setting out the offsets. Okay, now so then we can join all the offsets. Then the joining line will form a curve. That's all. It will be the curve here. Okay, now only that's all. From T1 we can draw number of offsets from the tangent line till apex, and from T2 we can draw number of offset lines with equal intervals till B. Okay, and then we can draw all the offsets. So then definitely it will form a curve. Okay, so that's all. This is the method of the setting out a curve by using the offset method. Okay, and one more method is there. That is the method which, from in that case, the offsets will be kept. In that case, first of all we will decide the T1 and T2 on the both the tangents or both the straights, and then we will draw a straight line from T1 to T2. That straight line will act as the, you can see here, that straight line from T1 to T2 will act as the length of long chord of the curve. Okay, so then from that long chord we can draw different offsets by calculating its OX. Okay, now so then after drawing the offsets from the long chord, we can connect all the offsets. Then that offset, the connected line will form the curve. That's all. Okay, now so by using any of the methods, we can set up the curve here. Okay, now so that's all. Okay, now guys, this is about curves. And Chapandi, if you want to discuss anything about curves, you can discuss, or you can tell to me. Any doubts in curve setting? Anybody can answer, na? Chapandi, ఏమైనా డౌట్లు ఉన్నాయి? Anybody have any doubts in curve setting? 21 BK, 121, are you there? 124, 125, 26, 29, 30. Yeah, any doubts in curve setting? Okay, curves, it means that there are two types of curves are there. One is horizontal curve and another one is the vertical curve. Okay, now so again in horizontal curves, two types of curves are there. Circular curve and transition curve. Okay, now so again it means that again one more classification is there, that is based upon the combination of circular curves. Okay, now so one is the simple circular curve. It means that whenever we have only one circular curve, it will be called as a simple circular curve, and whenever we two circular curves have been joined together, it will be called as the compound curve. And whenever two circular curves have been joined together and then their bends are in different direction, in that case it will be called as the reverse curve. Okay, now and these are all the different methods. By using Rankins method and by using offset method, we can set out the curves in field. Okay, now in case of Rankins method, first of all we will calculate the deflection angle, tangent length, length of long curve, radius. Okay, now and apex distance, all the things we will calculate. Okay, now and then we directly with the calculated measurements we can set up the curve in the field. And in case of offset method, first of all we will calculate, we will fix the apex, and then we will fix the two tangents. It means that tangent points T1 and T2 we will fix, and then from T1 to apex and from T2 to apex in opposite directions we will set up number of offsets and we will join all the offsets. That offset will form the curve here. Okay, otherwise we will join T1 to T2. It means that it will form the long chord. Okay, so from the chord we will draw number of offsets in one direction. Okay, and then we will join all the offsets, then it will form a shape of curve. Okay, so that's all. These are the different methods of setting out curve in field. Okay, so this is about curve setting. Okay, now so okay, and then after this I'm going to discuss about the EDM, electronic distance measurement. Okay, now so electronic distance measurement, it is a one more method of surveying. Okay, now so in general, what do you mean by surveying? Surveying is nothing but art of taking measurements, or art of doing measurement will be called as the surveying. Ante. Okay, now that's all. Whenever you go somewhere and you take some measurements, and that is the process of measuring. Okay, now if you take population of a city, it is a process of surveying. Okay, now if you take count of number of schools in a town, that's all. It is a survey. If you count number of women, a number of men, number of girls, number of boys in a village or in a town, it means that you are taking count, or you are taking count of different people, children, boys, girls, women, men. That's all. That is a process of surveying. Okay, that's all. Whatever the thing you will count or whatever the thing you will measure, that process will be called as surveying here. Okay, now particularly whenever we come to civil engineering, in civil engineering we do take measurements of different points on the earth surface. Okay, now we can measure, take elevation of the point, or we can take width of the point. Understand, no? We can take its radius level. Understand, no? Or we can take its or we can take distance between two points. Understand, no? That's all. Or we can take angle between two lines which are starting at the same point. Okay, now these are all the different measurements we take in field. Okay, now so the taking of such measurements will be called as surveying here. Okay, now so that measurements can be taken by using different methods. One is the direct distance measurement. It will be called as the DDM. Direct distance measurement means directly by using tape or by using chain we can take measurements. That will be called as the DDM. It means direct distance measurement. Okay, and one more method is there, that is the ODM, optical distance measurement. Okay, in optical distance measurement we can take angles first of all. Okay, now and then by using that angles we apply some formula, and then we can calculate the distance between the 2 points, or we and then we can measure or we can determine the height or elevations of particular points. Okay, now so in this case this kind of taking measurements will be called as the optical distance measurement. Okay, now it is written here clearly, you can see that First one is the DDM, or direct distance measurement. Okay, you can see here this is mainly done by chaining or taping. Yeah, and another one is the ODM. It means optical distance measurement. Okay, so this measurement is conducted by tachometry or theodolite or substance method or telemetric method. It means tachometer, theodolite, electronic theodolite, total station, all the things can be called as the ODM or optical distance measurements. Okay, this kind of surveying can become under ODM, optical distance measurement. Okay? And one more thing is that is EDM, electronic distance measurement. Okay? It means that in this case we don't do any calculation. In case of chain survey, we do some calculation, and in case of theodolite survey, tachometric survey, trigonometric leveling, and all the things also we will do some calculation there. We use some formula, and then we do calculation, we get the result, or we get the area, we get the distance, we get the elevation, all the things there. Okay, but here in case of EDM, electronic distance measurement, EDM. Okay, so electronically or electromagnetically directly we will measure the distance between 2 points. Okay, or directly we can measure the angle between 2 points. Directly we can measure the area within a boundary without doing any calculation. We can take that measurements, we can draw the maps. Okay, so that kind of surveying will be called as the EDM, or electronic distance survey. Sorry, electronic distance measurement or electromagnetic distance measurement. Okay, now you can see here most of the cases two kinds of instruments will be used for EDM. One is the total station and another one is the GPS. Okay, now so TS and GPS. TS means total station, GPS means global positioning system. Okay, so these are the two kinds of instruments will be used for EDM, electronic distance measurement, GPS, global positioning system. Okay, now you can see first we will see about total station, and then we will see about the GPS. Understand? You can see first you see what is EDM, electronic distance measurement. Okay, now so electronic distance measuring instrument is a surveying instrument for measuring distance electronically between 2 points through electromagnetic waves. Okay, now so this kind of method of surveying can be called as the EDM, electronic distance measurement, and that instrument will be called as the electronic instrument simply. Okay, now two kinds of instruments will be used. One is the total station, it will be like this, and another one is the GPS. Okay, now so GPS it will work based upon the satellite communication. Okay, now even nowadays everybody we are also having GPS in our mobile. Okay, it will receive the signals from the satellite, and then it will show the distance from one point to the another point. Okay, it means that from if you type Secunderabad. Okay, so then directly from St. Peter's Engineering College to the Secunderabad, it will show how much distance was there, how many 10 kilometer, 20 kilometer, like that it will show directly. Okay, so it means that in this case we need not to do any work in case of EDM. We directly whatever you want, you can give that commands to the instrument, and directly it will give you the result. It will give you the area, it will give you the distance, it will give you the elevation of the objects, and all the things it will do. That's all. Okay, that's why this method will be called as the electronic distance measurement. Okay, now so we will discuss about GPS survey and the total station survey now. Understand now? So that's all we want to know about much about EDM. Okay, now all the things are not a part. Directly we will discuss about the what we call total station and GPS. Okay, now total station, in this we will see what is electronic distance measurement and what is the principle of total station, what are the different parts of total station, and all the things we will see here. Okay, now so I think it is better instead of I'm explaining, it's better if you see video. Okay, now because anyhow this is online class now. You see the video how to work with total station and GPS, you will understand better. Okay, now I will show you the video. In between, if you feel any inconvenience or if you feel any doubt, you can, or if you want to share anything, you can type in chat box or you can call me and you can tell me. Okay, now I'm going to play the video. That's all. for total station. Okay now. Anyhow, in next we are also going to do some experiments on total station, and in next semester we will have GPS. Okay, now we are in 2-1 now. In 2-2 we will have GPS lab. Okay now. In next time completely we will work with GPS and lidar. Lidar is one more kind of electronic distance measurement instrument, EDM survey. Okay now, so we will work on GPS and lidar in next sem. Okay, now we will see about total station and GPS. See the video, it's better. From video we'll understand better. Okay, instead of showing PPT or instead of I'm explaining here, see the video, we'll understand. Okay now guys, the video is visible to all of you. Video కనిపిస్తుందా లేదా?
Yes, sir.
Okay, see.
In this video, we're going to look at how to
Is it audible now?
Yes, sir.
use a total station. First, we'll look at some of the features of a total station, and then we'll look at some of the basics on how to use it. This here is a total station. It's a tool that we use for surveying to take distance, angle, and elevation measurements. The total station works by measuring from our lens to a prism mounted on a pole, and using that we can determine the distance from the total station to the prism, an angle between multiple prisms, and using that information determine the elevation of the ground at the base of the prism. Let's look at the features on the total station. Again, we have our optical lens, we have our display screen, a leveling base, and a tripod that we've set the total station on. If we look at our lens,
Explaining each and every component of the total station. Okay now, see here, first you see there, then you can ask me. Okay now.
we have an outer ring that adjusts the focus. We have an inner ring that adjusts the focus of a crosshair, and those help us sight the prism and make sure the prism is centered in our view. We also have a knob here and a knob here. This knob on the inside locks our horizontal rotation, and this knob is a fine adjustment for the horizontal rotation that helps us sight a prism, especially a prism that's far away. And this knob locks our vertical rotation, and this knob is a fine adjustment for the vertical rotation. When we set up our total station, it's important to know the height of our instrument. So a total station has this little line marked on the side, and that's the center line of the lens. And so for determining our height of instrument, we want to measure from that center line to the top of the object that we've set up our total station over, such as a nail in the ground. Next, let's look at the total station display. So we have our power button to turn on and off. For modes, we have our angle measurement, distance measurement, and coordinates measurements mode. We have some features we can access through menu and the star button. We have escape and enter buttons, a keypad to input data, and then 4 function keys F1 through F4 that we can push to use modes within angle and distance and coordinates measurements. Let's look at how to use the total station. The first thing we'll do is turn on our laser plummet. So that's a laser that comes out the base of the total station, and that shows us the exact point that we've set up our total station over. So to access that, we can push the star button, and for F3, that turns our laser on. As you can see, our laser turns on. On some models, this is not a built-in feature, and there's an external laser, and for that, there's a big red button on the side of the total station. You push that button, and that would turn our laser on. Next, let's look at our angle mode. We'll use this mode to measure the angle between multiple points, and we can also use this mode to set our horizontal rotation angle to 0. We can access the mode by pushing the angle mode button. We'll see V for our vertical rotation displayed on the screen, and HR for horizontal rotation displayed on the screen. We can see the way I've set this up, our horizontal rotation is currently some kind of random angle. So what we want to do, we sight our first prism. I've gone ahead and done that, and we'll set our horizontal rotation to 0. So we push F1 to 0 set, F3, yes, we want to set that angle to 0, and we can see our horizontal rotation becomes 0 degrees, 0 minutes, 0 seconds. We can now measure from that point to a second point, so our second prism. We sight our second prism. So sighting that second prism, we can see our horizontal rotation between the 2 prisms is 11 degrees, 58 minutes, 10 seconds. Next, we'll look at our distance measurement mode. To access that, we can push our distance measurement mode button, And that will take us to a screen that shows the horizontal rotation, HR, the horizontal distance, HD, and the vertical distance, VD. The total station takes a measurement, distance measurement directly from the lens to the prism, and using Pythagorean theory displays the two sides of that right angle triangle. So that being our horizontal and vertical distances are the two sides of a right angle triangle. We can see the slope distance by pushing our distance measurement mode button again. So we see SD for our slope distance. But for surveying, we often want to record this information as the two sides of our right angle triangle. So HD and VD. It typically starts by taking a measurement automatically, but now if I stay in this mode and maybe I sight a second prism and I want to take another mode or another measurement, we can push F1 to take another measurement and keep pushing that over and over again as many times as we want to take measurements. When using the distance measurement mode, we look at our vertical distance. If our prism is higher than our total station, this value is positive. So here our prism is higher by 0.862 meters. If our total station is set up higher than our prism, this value will be negative. So those are the basics for using a total station. With that information, you can use the total station to sight a prism, set your horizontal angle to 0, take a distance measurement, and measure the angle between multiple prisms. There are a few other little tricks that will help use the total station more efficiently. For one example, if we rotate our total station clockwise, our horizontal rotation counts up. And if we rotate counterclockwise, it starts at 360 degrees and counts down. We may want to change that to the opposite rotation. So if we push F4 2 times, we get to level P3, and we can push F2 to change that rotation from right to left or clockwise to counterclockwise. So if I push that, now rotating clockwise from our 0 counts down from 360, and rotating counterclockwise counts up. We can also change our units. So I'm filming here in Canada, so we're using metric, and we may want to use feet or inches. So if we go to our distance measurement mode, we can push P1 to get to P2. And for F3, we see we have meters, feet, and inches. So we can change to feet. You can see that changes to F, change to inches, and back to meters. Also, if we look at our star button, we have some display options here. So we can turn a backlight off and on. Pushing F1 turns that backlight off and on. I've had it on for filming to make the screen a little bit brighter. And we can also change our contrast on our screen by pushing the up and down buttons, which are also the distance and angle measurement mode buttons. If I push it up, you can see the screen kind of disappears, and all the way down makes it disappear. So you can adjust that based on how bright it is outside, and to make that easier to read. And then often I find students get stuck in this star mode and don't know how to get out. If I push angle, nothing happens, angle or distance, nothing happens. So we just want to hit our escape key to get out of that. Thank you for watching my video. You can check out my other videos on how to set up and level a total station and how to use a data.
Hi, I'm Wes. Welcome to Lecture 1. In today's show, we'll reintroduce the total station, review some functions and commands, and introduce a data collector.
This here is a total station. It's a tool that we use for surveying to take distance, angle, and elevation measurements. The total station works by measuring from our lens to a prism mounted on a pole, and using that we can determine the distance from the total station to the prism, an angle between multiple prisms, and using that information determine the elevation of the ground at the base of the prism. Let's look at some of the features that we have on our total station. So we have an objective lens. We can look through that lens and sight our prism, and that lens also takes our shots for us. We have a display screen, and we have a base that we can use to make the total station level. Let's look at the features on the total station. Again, we have our optical lens, we have our display screen, a leveling base, and a tripod that we've set the total station on. If we look at our lens, we have an outer ring that adjusts the focus. We have an inner ring that adjusts the focus of a crosshair, and those help us sight the prism and make sure the prism is centered in our view. We also have a knob here and a knob here. This knob on the inside locks our horizontal rotation, and this knob is a fine adjustment for the horizontal rotation that helps us sight a prism, especially a prism that's far away. And this knob locks our vertical rotation, and this knob is a fine adjustment for the vertical rotation. When we set up our total station, it's important to know the height of our instrument. So a total station has this little line marked on the side, and that's the center line of the lens. And so for determining our height of instrument, we want to measure from that center line to the top of the object that we've set up our total station over, such as a nail in the ground. Next, let's look at the total station display. So we have our power button to turn on and off. For modes, we have our angle measurement, distance measurement, and coordinates measurements mode. We have some features we can access through menu and the star button. We have escape and enter buttons, a keypad to input data, and then 4 function keys F1 through F4 that we can push to use modes within angle and distance and coordinates measurements. When we're surveying using a total station, we're often just using the distance and angle measurement modes, and then star and menu buttons to access some of the features, and the F keys to use some of the features within distance and angle measurement. And we compare our total station with a handheld computer called a data collector, and that really enhances what the total station can do. Let's look at how to use the total station. The first thing we'll do is turn on our laser plummet. So that's a laser that comes out the base of the total station, and that shows us the exact point that we've set up our total station over. So to access that, we can push the star button, and for F3, that turns our laser on. So you can see our laser turns on. On some models, this is not a built-in feature, and there's an external laser, and for that, there's a big red button on the side of the total station. You push that button, and that would turn our laser on. Next, let's look at our angle mode. We'll use this mode to measure the angle between multiple points, and we can also use this mode to set our horizontal rotation angle to 0. We can access the mode by pushing the angle mode button. We'll see V for our vertical rotation displayed on the screen, and HR for horizontal rotation displayed on the screen. We can see the way I've set this up, our horizontal rotation is currently some kind of random angle. So what we want to do, we sight our first prism. I've gone ahead and done that, and we'll set our horizontal rotation to 0. So we push F1 to 0 set, F3, yes, we want to set that angle to 0. And we can see our horizontal rotation becomes 0 degrees, 0 minutes, 0 seconds. We can now measure from that point to a second point, so our second prism. We sight our second prism. So sighting that second prism, we can see our horizontal rotation between the two prisms is 11 degrees, 58 minutes, 10 seconds. Next, we'll look at our distance measurement mode. To access that, we can push our distance measurement mode button, and that will take us to a screen that shows the horizontal rotation, HR, the horizontal distance, HD, and the vertical distance, VD. The total station takes a measurement, distance measurement directly from the lens to the prism, and using Pythagorean theory displays the two sides of that right angle triangle, so that being our horizontal and vertical distances are the two sides of a right angle triangle. We can see the slope distance by pushing our distance measurement mode button again. So we see SD for our slope distance. But for surveying, we often want to record this information as the two sides of our right angle triangle. So HD and VD. It typically starts by taking a measurement automatically. But now if I stay in this mode and maybe I sight a second prism and I want to take another mode or another measurement, we can push F1 to take another measurement and keep pushing that over and over again as many times as we want to take measurements. When using the distance measurement mode, we look at our vertical distance. If our prism is higher than our total station, this value is positive. So here our prism is higher by 0.862 meters. If our total station is set up higher than our prism, this value will be negative. So those are the basics for using a total station. With that information, you can use the total station to sight a prism, set your horizontal angle to 0, take a distance measurement, and measure the angle between multiple prisms. There are a few other little tricks that will help use the total station more efficiently. For one example, if we rotate our total station clockwise, our horizontal rotation counts up. And if we rotate counterclockwise, it starts at 360 degrees and counts down. We may want to change that to the opposite rotation. So if we push F4 2 times, we get to level P3, and we can push F2 to change that rotation from
21 BK 580 140. You want to speak anything? Okay.
from right to left or clockwise to counterclockwise. So if I push that, now rotating clockwise from R0 counts down from 360, and rotating counterclockwise counts up. If I push that again, it goes back to the other way. So at R0, now turning clockwise counts up, counterclockwise counts down from 360. We can also change our units. So I'm filming here in Canada, so we're using metric, and we may want to use feet or inches. So if we go to our distance measurement mode, we can push P1 to get to P2. And for F3, we see we have meters, feet, and inches. So we can change to feet. You can see that changes to F, change to inches, and back to meters. Also, if we look at our star button, we have some display options here. So we can turn a backlight off and on. Pushing F1 turns that backlight off and on. I've had it on for filming to make the screen a little bit brighter. And we can also change our contrast on our screen by pushing the up and down buttons, which are also the distance and angle measurement mode buttons. If I push it up, you can see the screen kind of disappears, and all the way down makes it disappear. So you can adjust that based on how bright it is outside, and to make that easier to read. And then often I find students get stuck in this star mode and don't know how to get out. If I push angle, nothing happens. Angle or distance, nothing happens. So we just want to hit our escape key to get out of that.
If you want a refresher on how to set up and level a total station, click on the link here to watch a 60-second video on how to set up and level a total station. A data collector is a handheld computer that looks something like this. The most important part for surveying is the software called Magnet Field. This software is what allows us to enhance and digitize our surveys. So what can Magnet do? First, the software helps you locate your instrument within a coordinate system using a 2-point resection for a total station and a localization for a GPS rover. No more doing hand calculations to try and find your occupy point. With your instrument location mapped, you can digitally collect the northing, easting, and elevation of each point in your survey. And you can see these points in a map view. And then after collecting all your information, export into another software such as AutoCAD or Civil 3D. The software also allows you to label each point. So you can call one point a tree as you survey a tree, and another point a, say, fire hydrant when you survey a fire hydrant, as you go through and complete your survey. You can also add lines to connect between points. So as you survey something linear as, say, a curve, you can add a line to delineate that curve and then have that information as you export into some other software package. We'll get into detail of each aspect that I've mentioned here throughout this course. Let's look at how to open Magnet, create a new job, and connect our data collector to a total station. On the data collector, we'll open Magnet, choose the job folder, and select New Job. We can name the job, add info as needed, and hit Next. Here we'll make sure we have the correct configuration. In our labs, we have this already set up, so we can hit the green check mark at the top right corner of the screen and go back to the home menu. Now we have a new job set up, and we can check that by making sure the name of our new job is displayed in the top of the screen. Next, we'll connect to our total station. Hit Connect, and we'll make sure we choose the right hardware for our survey. Here we're connecting to a conventional total station, so we'll select Optical, choose the conventional total station, we'll hit Connect, and we'll get a screen that displays the model number of our total station. Make sure you choose the model number of your specific total station and hit Select and Connect. Now we have a new job set up and our data collector connected. Thank you for watching this lecture. In our next lecture, Lecture 2, we'll talk about how to complete a topographic survey, how to use point codes, and how to take a topographic shot or a
Yeah, guys, this is about the total station. Okay, so different components of total station and their use and how to connect the total station to the system and how to draw the maps by using total station and how to convert the data into digital. Understand? Anna? So all of this is about the total station. And anyhow, we are going to see about this in. We are going to see it in our lab. We are going to work it. We are going to work on the total station in our lab. Okay, now. This is about total station. Till now, yeah, it will have one total station, one tripod and one prism. Till wherever you want to take measurements, okay, at that particular place we can place the prism, and then till that we can take the measurements. Okay, in this no calculation will be there. This is the total station and this is the prism. By using these two equipment only we are going to perform all the survey here. Okay, now so an electromagnetic ray will pass from the telescope of the total station and then it will reflect on the prism. Okay, now so then it can automatically it can measure how much distance the ray have been passed, and then the distance it means that it will show the distance. Okay, now so that's what only that's all. It can do all the calculations automatically. Okay, now so this is about the total station. Yeah, guys. Okay, and next our next concept is GPS, global positioning system. Okay, now so global positioning system, it is a satellite based radio navigation system for the determination of precise position of time, distances and etc. Okay, now so most of the cases it will use the data, it will receive the data from the satellite and other things. Okay, now so it will permit users with suitable receivers to establish their position, speed and time on land, sea. It means that air or wherever we want we can get the GPS data in our instruments or in our devices. Okay, and then we can enjoy the data or we can do our work upon the data. Okay, now. So that kind of survey will be called as a GPS survey or global positioning system. Okay, now so the GPS system will have especially three segments. Okay, now so one is the space segment and another one is the control segment and another one is the user segment. Okay, now so space segment is nothing but satellite. Okay, now so in space satellites will be there and the control segment it is nothing but the station where the upon the earth where we are tracking the satellites. Okay, now so in that is the most of the cases the remote sensing centers will be there now. Okay, now so there they will collect the data from the satellite and then they will distribute the data on the earth surface to different areas. Okay, now so that is called as the control segment and another one is the user segment. Okay, now the people or the users who are all using the GPS data. Okay, now so they will be called as the user segment. Okay, now so most of the cases, not most of the cases, everybody nowadays using GPS in their mobiles. Okay, now so in this case the satellite will come under space segment and the remote sensing center will come under control segment and the user or the one who is using the mobile will come under the user segment. Okay, now so in GPS system basically three segments will be there and you can see in space around the earth different satellites are rotating. Okay, now most of the cases 24 you can see 24 satellites are rotating nowadays in the around the earth surface. You can see there. Okay, now like this and then the satellites will send data. Okay, and anyhow the orbit in which the satellites will move, they are to 20,200 kilometers up, away from the earth surface or away from the earth. Okay, now and these satellites are grouped into 6 orbits and they are inclined 50 degrees to each equatorial plane and evenly spaced at 60 degrees apart. Okay, now so this is the data. It means that what you call satellite will be there, control segment will be there and user segment will be there. Okay, so our most thing is that how to, it means that receiving the data from the satellite and then processing the data and then distributing the data to different devices or to different instruments. It means that among the users. Okay, so that is the major thing here. Okay, now so different equipment will be used for receiving the data and processing the data. Okay, now so that is also one of the important thing. Okay, now so you can see a video on this. Okay, now so later we will have discussion about the GPS. Okay, now so how to use the equipment and how to process, how to set up the equipment and how to collect the data. That is the important thing. Okay, now so simply GPS is nothing but a global positioning system. In GPS, we will collect the data from it, satellite. We will receive the data and we will process the data, and then we will distribute the data among the users. Okay, so that's all. This is about GPS. Okay, so how to set up the instrument and how to work on it. This is the important, most important thing. Okay, so you can see a video for the GPS also. Okay, I will understand better. See here.
Welcome friends. Today I am going to demonstrate the different methods of GPS surveying. Now to start with, as I already told that in GPS surveying there are different methods like single point positioning, relative positioning, and under relative positioning there are different ways we can do it, like static surveying, kinematic surveying, and again kinematic surveying. There may be stop and go convenient to your height. Fix karo. This is the trivac and this is the antenna adapter. Both are put together, and before we are placing it on the head of the tripod stand, we have to take these foot screws in the middle between the trivac and trivac, so that approximate leveling is to be done, and that you can see
I will
through this
forwarding the
bubble. There is a for our surveying work as possible from the antenna, because otherwise the signal with this is the see through this bubble. There is a bubble where you can see about the leveling part. Now we will fix it. चलो पहले middle में आ गया. So this is the optical plummet of the instrument through which we look through to see whether our centering is just at on this tip or not. Now by adjusting this tripod leg, we have to make it level. Leveling we will be able to understand by seeing the bubble at the bubble tube. It should be at the center of this bubble tube. So now it is level. Now we have to check whether centering has been done. Now this part has been centered properly as well as level. This is a very important operation to reduce the amount of grass error, as I had discussed in errors in GPS observation class. Now we will fix the antenna. This is a very high-ended antenna called geodetic Jeffrey antenna, which removes the multipath errors. So now we are fixing it. So taking the adapter here, placing it. So this is how we have placed the antenna. Now we will connect our antenna with the GPS receiver. Now this antenna will be connected using this connector to this.
Yeah, guys, see how they are connecting the antenna to the GPS receiver. Okay, now so most of the cases, antenna will collect the data from the satellites. Okay, now in our laboratory also we are having such antennas and we are having that GPS receivers. Okay, now so next lab, it means that in next semester we will perform experiments on GPS surveying. Okay, now so now we will see how to work and how what are the devices will be used for GPS survey and how to work with them. You can see here. Okay, now.
Receiver. So in this receiver there is a symbol where it will be easily understood where you have to make it. So there is a symbol of GPS. So because this antenna will receive the GPS signal. So we will be, so now it is connected. Next we will connect with this receiver the controller. So already I had shown in the class, this is the controller which we will be using here. So one end of the controller will be placed here and the other end will be kept here. So after this we have to, so the battery is already within this part as well as this part, so we don't need any external battery for our work. Now we can start. So one thing we should note that after connection is over, we should be as far away as possible from the antenna, because otherwise the signal will come GPS from our head also, it can go to here, which may cause multipath. Now you can see our arrangement. We have open sky, and you can see if we take an approximately 10 degree or 15 degree, so there will not be any obstruction, physical obstruction. So that is very important. So we have taken our reference station on the top of the roof. After the receiver has been set up, that means antenna has been centered and level on the point or reference station, and the proper connection with the receiver as well as controller. First we have to make this controller open, so that after opening we get this screen. Now from the start menu we can go inside and we can see the Trimble Access is the field software which is to be used for our surveying work. So this is to be opened. Now it is opening. So this is the first menu. So now we have to open the general survey. So here you can see here the 95% is the amount of battery charges that is available here. Then the then another 91% is for from the receiver. So anyway, so now here you can see the satellite. There are 8 satellites we get connected, and the our controller is properly connected with the receiver. So it is giving an antenna is also properly installed. So now we have to go for jobs. We have to create a new job. So we have to give a name. Let us say the job name is job 1. First job 1, and keeping all other parameters okay. Now we will not be changing any other parameters. So we can also COGO settings, we can do it here. The now start base receiver, since this is the reference station and also it is called base receiver, so we are starting the base receiver, and we can give a name to this point. Let us say this is the point, our reference point. So roof top reference. So this is the name given to it. So now we had to measure the antenna height. Now antenna height can be measured. This is the way how we do take. This is called slant height, and the height is how much? 1.09. 1.09. I am to fit it and measure to bottom of notch. So now I can start taking observation. So starting survey, this the base started. Okay. So now the measurements are being taken by through the antenna to the receiver, and the observations are being recorded inside the receiver. Now we can exit out of it. Now it will be continuing to take. In the meantime, we can go for next method. Now we will be demonstrating the real-time kinematic surveying. So after setting up the reference station, we have to set up another station called communication setup. So here also we will first take a tripod stand where we will take on the antenna setup, we will take a radio communication antenna. So this is the communication antenna. Which has to be connected to a stand so that the antenna height gets high enough so that the communication can go far off. So this is an arrangement so that no bird can strikes on it. So the receiver, this is the receiver. After getting our receiver and the communication antenna installed, we have to go for our field software to be operated to communicate from reference station to rover station. So start with a job. So usually we go for a job which is already opened and where the data for the reference receiver is already there. That means we need to take a station whose location is known. So this is a job we are taking. So now we will start measurement. So under the measure there are different types. We are to going for RTK, so clocking. So first we have to start base receiver. So clicking base receiver we are getting. Now under point name we have to take a name which already we have taken the data, that means known point. So base, so we have taken and we can start now. So now you can see that base has been started. Okay. Now the reference receiver from reference or base receiver, this radio communication is communicated through that radio communication systems. So now we have to go for this radio communication to rover station. After the fixing and communication unit of the reference station has been set up, now we will go for setting up of the rover station. First, this is a rover antenna, which is also a Jeffrey antenna, which will be fixed with a vertical stand having two legs, that is called dipod legs. Now this will be placed in a vertical condition using these dipods, so that here we have the bubble which gives us the impression about the level. So after it is fairly level, we will fix up the receiver with the stand, and then there will be connection between the antenna and the receiver. Then also we have to fix, this is the antenna, receiving antenna to be connected to the receiver, that is called rover antenna, and then we have to connect the controller, starting survey. So we have given this rover 6 name. So measure. So as we have given the name measurement, it is measuring. Now you can see here RTK fixed, all this is given, so I can store it. So observation has been stored in RTK mode. Now we can take this rover to some other station, and again we can do the same operation to measure the point on RTK mode. With this we can conclude the RTK survey. Now after our reference station has been set up at the reference location, or base station has been set up as a reference station, now we will be setting up the rover station for our relative static positioning. So this is the point whose location we need to find out. So we have to centered as well as leveled our tripod stand on this point. So similar to what we did in the in case of reference station, we are doing the same thing. First we are opening the tripod stand, and we have placed it here, and now we will make it leveled and centered. This is the optical plummet through which we see about the centering, and this is the cross bubble which provides us the level part. So now this tripod stand has been centered as well as leveled. Now we will be fixing up the Zephyr antenna, and we are placing it on the tripod. So after the antenna has been placed on a centered and level tripod stand, now we will be connecting the antenna with the rover receiver. So again on that port where GPS has been written, and with this rover now we have to connect the controller. We are placing the receiver in the tripod stand way. Job. Since
The same operation we will perform here.
method,
We performed again.
so we are getting it. If we go and take
it. Okay, you can watch from here how to.
So
Yeah.
once the observation is over,
Satellites. Okay, now how we have to receive and how we have to process the data. Okay, now so that is the only most important scenario here. As you can see here only for this. Okay, now so with this you can understand complete how to work with GPS survey. Okay, now so if you learn this, it means that only alone. Only it means that if you learn total station alone, we will have more job opportunities. Okay, now if you know about how to work with remote sensing or how to work with GPS, also we will have plenty of opportunities outside this. Okay, now so that's why the only thing is that whenever we have time, we have to learn the concept. అంతే కదా ఫస్ట్ మనం నేర్చుకోవాలి. We have to learn the thing first of all. Okay, now so we have to learn the technology first. Okay, now so that's why you listen this. Okay, now so if you have any doubt, you can ask me. Again, I will explain you. Okay, now so in this video they are showing clearly. Okay, now so different devices will be used for GPS survey and how to operate them, how to connect them, how to receive the data, how to process the data, and how to get the output. Okay, now everything they are showing here. Okay, now so definitely this video will be highly useful for you if you watch it clearly. Okay, now so watch clearly, understand it. Definitely it will be useful for you. Okay, so he is the professor from IIT Kharagpur. Okay, the man who is standing in this video, no, he is the professor from IIT Kharagpur. Okay, so you please watch it clearly.
then we can stop by giving abundant points. Yes. So we are about to complete our observation of. So you are now completing it. So only 14 seconds, now 12 seconds, 11 seconds.
Observation stored.
So you see, once it is observation is over, again it is telling measure. That means we can go to next point and we can take our next observation. Now I will demonstrate you the relative method of surveying, which is of stop and go type, in which we have already set up the reference receiver in the reference station, and now we will be setting up our rover station. Before taking the measurement in this method, first we have to go for initialization. Now here you see that we have done the we have placed the antenna on a point after properly leveled and centered, and this is a temporary point where we will be initializing. We will do the initialization process. Now in order to do, after doing the necessary connection as did in case of rover receiver in relative positioning, we did the same thing, only we had done it in a different station point, and now we have to do the initialization process. For that, after the opening the field software Trimble access general survey, we go again. We should go for a new job. Suppose we are giving the name as job stop and go, enter, accept. Okay, now next, after opening, we should go for measurement. It is the TPK, so measure points. So it has started the post processing kinematic positioning. So let us say the name as Rover 6, and the antenna height we have measured as 2 meter. So we kept it. So enter, measure. So after opening the job, we want to go to, we are now starting measurement. So before starting the measurement, we should go for initialization. So we are doing the initialization process in it. So new point, we are taking a new point, start. So here and the antenna height, so it will require 15 minutes time to initialize the process. Stop and go method. First, after initialization, we have stopped. So after keeping the stand just at the center of the point and making it a bit level, through this bubble we can get the leveling. Now I am starting measurement of the next point. So the measurement is over. Now I can store it. Now one thing we should keep it in mind, that during measurement we should keep hold without making any movement. Anyway, so now the name has been changed automatically to Rover 9, which will be the name of the next point. So this is the third point which we want to measure, whose name is Rover 9. So as we have centered it, leveled it, now I will start measurement. So now we can store it. So we can go to the next point. Let us go to the next point. Initialization has been lost. So it is the robot 10. After leveling and centering, we have started measurement. Now store. So in this way, we can go on continuing our measurement and define points, salient points, and we can further during post-processing, we can get the position. So with this, I want to conclude about our demonstration of stop and go method. So already we know how to carry out the kinematic GPS surveying. First, what we did, we have set up our reference station or base receiver to the reference station. Then we had taken the rover receiver to some initialization point and we completed our initialization. And after the initialization, now we will do the actual measurement of the uh, kinematic positioning. To start with kinematic surveying with the rover survey, first we have to create a new job. In the job, we have to do our initialization, which is being done. Stop and go method, kinematic method, and also finally I had shown you the real-time kinematic method. With this, I like to conclude today's class. See you in the next class. Thank you.
Yes, this is that what are the devices will be used for GPS survey and how to work within it. Okay, it is very simple. If you have device, GPS device, and if you have an antenna, okay, now we can fix that antenna to the tripod. Okay, and then the remaining apparatus, it means that how to, it is like using mobile. Okay, now so మన దగ్గర మొబైల్ ఉందనుకో, how we will operate the mobile. In the same way we can operate the GPS device. Okay, now in the same way, if you how to if you know how to operate the mobile, in the same way you can also operate the instrument total station to do the survey. Okay, that's it. It means that this doing survey with the total station or GPS, it is too much easy. It's very easy. Okay, so if the device is given to you without having any explanation, directly you can do it up. It means that some basics to be known. It means that what is the device and what are the different components of the device, and what is their use, what is their purpose if it is known to you. Okay, so definitely you can work with them and you can do survey. Okay, and then you can accomplish the results whatever required. Understand or no? Okay guys, today in today's class we have been discussed about the curves, total station, and GPS, global positioning system. Okay, now. Okay, thank you very much. If you want to speak or if you want to ask anything, you can ask me. Anybody wants to speak anything or wants to ask anything, you can ask me.
Okay, bye, sir.
Okay, thank you. Still, if you have any doubts, you can tell me.
సార్ వీడియో క్లియర్ గా విజిబుల్ కాలేదు సార్, ఆ వీడియో లింక్ పెట్టండి సార్.
వీడియో
అంటే
క్లియర్
కొన్ని point-
కనిపించలేదా మీకు?
లేదు సార్, అంటే కనిపించలేదు.
చక్కగా
అంటే కొన్ని
కనిపిస్తలేదు
పాయింట్స్
సార్.
ఉంటాయి కదా సార్ మిడిల్
ఆ,
అది జాబ్ అవన్నీ.
ఓకే, లింక్ షేర్ చేస్తాను మీకు అది.
ఓకే
అది ఎన్పిటిఎల్ వీడియో, మీకు ఎన్పిటిఎల్ కోర్సెస్ జాయిన్ అవ్వమంటారు కదా.
జాయిన్ అయినాం సార్.
ఇట్ ఈస్ ఎన్పిటిఎల్ వీడియో ఆఫ్ సర్వేయింగ్. షేర్ చేస్తాను మీకు, లింక్ షేర్ చేస్తాను. ఓకేనా?
ఓకే సార్.
ఎనీహౌ జీపీఎస్ సర్వే వి విల్ డూ నెక్స్ట్ సెమ్. మన ల్యాబ్లో కూడా ఎక్విప్మెంట్ ఉంది, వి విల్ పర్ఫార్మ్ ఇన్ నెక్స్ట్ సెమ్. టోటల్ స్టేషన్ అంటే ఈ సెమ్లోనే ఉంటుంది మనకి. నెక్స్ట్ రేపు హాలిడేస్ నుంచి వచ్చినాక వి విల్ స్టార్ట్ విత్ దట్.
ఓకే సార్.
ఓకే, కంపేర్ టు చైన్ సర్వే, కంపాస్ సర్వే, థియోడోలైట్, ట్రిగ్నోమెట్రిక్ లెవెలింగ్, వాటితో కంపేర్ చేసినప్పుడు ఈడిఎం మనకు చాలా ఈజీ ఉంటుంది. ఎందుకంటే మనకి ప్రాబ్లమాటిక్ పార్ట్ ఉండదు, క్యాలిక్యులేషన్ పార్ట్ ఉండదు. ఓన్లీ సర్వే చేయటమే, ఓన్లీ డేటా కలెక్ట్ చేసుకోవటం అంతే. దట్స్ ఆల్. It will do every calculation on itself. Too much. Okay guys, all of you can leave class now.
Okay, thank you, sir.
Okay.